Good morning, ladies and gentlemen. Apologies for the late start. My name is Mthetho Sovara from the National Integrated Cyber Infrastructure System. This morning, I'm going to be talking to you about forecasting the future. That basically entails building AI-powered weather models using the Python ecosystem in an African HPC context. So climate change, I think we all know what that is not a future threat for Africa. It's a present reality, affecting millions of lives daily. And our continent faces a range of extreme weather events, from prolonged droughts in the east and southern Africa to catastrophic flooding in the west and central Africa. We are also seeing more intense tropical cyclones affecting coastal regions and record-breaking heat waves across North Africa and the Sahel. These events create urgent challenges for our communities and economies. They affect agriculture, water resources, public health, and infrastructure. Now, forecasting these events remains a major challenge, particularly in Africa, because we have limited observation networks, complex climate systems, and resource constraints. So we are unable to make accurate, localized predictions. And this is where AI-driven forecasting can make a critical difference, especially when made accessible through tools like the Lengau API, which I'll get into a bit later. So what got me into this was actually an international competition called the AI WeatherQuest competition. So the AI WeatherQuest is an international competition organized by the European Center for Medium Range Weather Forecasting. ECMWF is an independent intergovernmental organization supported by over 30 European countries, and it plays a central role in global weather and climate prediction. So the AI WeatherQuest competition basically challenges participants to develop machine learning models for improved sub-seasonal, that is intra-seasonal forecasting, basically forecasting 2 to 6 weeks ahead. Or specifically, we need to predict global temperature and precipitation with quantile probabilities at a 1.5 degree lat-long grid for the days 19 to 25 and the day 26 to 32. The standard approach leverages the Python-based Anemoi framework. So in 2025, the Anemoi framework won the EMS Technology Achievement Award granted by the European Meteorological Society. The award cited Anemoi's innovation in enhanced forecast accuracy using machine learning techniques, its flexibility, scalability, and its open source access, which allows various stakeholders to adapt cutting-edge forecasting tools. So at the CHPC, my approach has been to leverage the Anemoi framework by deploying it on high-performance computing infrastructure and optimizing its models for African climate patterns. And this effort has led to the development of a custom CHPC API designed to accelerate model training, inference, and visualization, making advanced climate forecasting more efficient and accessible. And by the way, the term Anemoi comes from Greek mythology. It refers to the gods of the winds. So, a little bit about myself. My work spans high-performance computing and system science, but I also support research programs in astrophysics and quantum physics. Now, my aim is to apply computational methods to help advance these research domains. I'm a senior research support scientist at the Center for High Performance Computing, and my interests are basically the intersection of the atmosphere and ocean sciences, HPC, and research software engineering. And there's a snapshot of my GitHub where I do all this kind of development. So basically what inspired the work I'll be talking about is this international competition and a job interview for industry. Now, our AI-driven weather forecasting workflow is built using Python and its powerful libraries. So this creates a smooth pipeline that transforms raw climate data into actionable insights. Some of the key tools we rely on include xarray, pandas, scikit-learn, PyTorch, matplotlib, cartopy. Now, Python is particularly well suited for African weather services because it's easier to learn and it uses, it's easier to learn than traditional Fortran-based models. It offers extensive documentation and learning resources. It has a growing community across the continent, as we've seen here. And our workflow demonstrates how these libraries come together from loading ERA 5 data through pre-processing and model training to final visualization, allowing us to generate accurate, timely, and actionable weather forecasts. So the radar chart you see there basically demonstrates that Python is has strong, well-rounded capabilities across all dimensions, with most areas scoring between 80 and 100. Basically, this chart shows us that Python is a versatile, mature, scientific computing platform with no major weaknesses, making it an excellent choice for data science and scientific computing workflows. Now, the Lengau supercomputer at the CHPC significantly accelerates this AI-driven weather forecasting workflow. The CHPC has 30 NVIDIA V100 devices that are currently oversubscribed. So more GPUs means we can reduce training time from weeks to hours and subsequently accelerate AI-driven weather forecasting across the global south. And the bar graph you see illustrates the performance gains achieved when scaling workflows on Lengau. Data processing and model training see the most significant improvements, while inference and visualization are lightweight enough to be efficiently handled on local machines. So our end-to-end workflow for AI-driven forecasting integrates the Anemoi framework with the supercomputer to create a robust forecasting system optimized for African contexts. The Anemoi framework provides several key components: Anemoi datasets for handling data processing, Anemoi training for model training, Anemoi inference for making the predictions, and for operational deployment. And this modular approach allows for flexibility and adaptation to different forecasting needs across Africa. So this flowchart demonstrates how we integrate these libraries in our workflow, from loading ERA 5 to pre-processing, model training, and visualization. So at this point, I shall motivate why there was a need for the Lengau Job Management API, and I'll present to you quickly a case study from a research program on the cluster that I recently did a report for. So the report, in the report, I noted the following to the principal investigator. And the report covered the period from March to September. So based on the system data, we could see that the program mostly ran small-scale jobs, serial or lightly parallel, with occasional larger parallel jobs. This suggests that their workflow is not heavily optimized for HPC parallel scaling. This research program submitted 668 jobs, and of that 668, 328 failed. That's almost half. 251 succeeded. This is about a 49% failure rate, which is very high. And so key insights from this report, I noted that most of their jobs use very few cores, wasting HPC potential. They had a high failure rate. Nearly half of all their jobs failed. Therefore, debugging and workflow refinement is needed. And the majority of allocated CPUs to them were idle, pointing out poor job configuration, that is, over requesting cores or not using MPI properly. These inefficiencies will be resolved by the Lengau Job Management API, which acts as a bridge between the user and the pipeline. So what you see here is the rich Python ecosystem, which is used to build the Anemoy pipeline. You've got your job management API, which acts as a bridge between your users and the AI pipeline. So the Lengau Job Submission API is our homegrown solution designed to close the gap between Africa's complex HPC infrastructure and the meteorological services that need it the most. It simplifies how users interact with the supercomputer by offering features like easy job submission, automatic resource optimization, built-in workflow management or task dependencies, strong error handling for network or node issues, and real-time performance monitoring. So when I compare traditional PBS job scripts to our API, the improvement is striking. What once required lengthy and complex batch scripts can now be done in just a few lines of Python. And so I predict a 90% reduction in the technical barriers to using HPC, allowing meteorologists to focus on science rather than system setup, and opening the door for operational AI-driven weather forecasting across the continent. So this is a snapshot of some of the current API endpoints. You see there's an endpoint for submitting jobs, endpoint for monitoring, and obviously this can grow in complexity by adding more endpoints. And so our workflow brings together established climate tools and custom frameworks, all coordinated through the Lengau API. We also use METplus for model verification, Anemoy for machine learning, model development, and the Lengau API to manage HPC workflows. So the API acts as a central orchestration layer connecting all components it manages. So some of the key benefits of this integration include standardized verification metrics, streamless data flow, efficient resource use, and reproducible workflows. Our AI-driven forecasting workflow powered by the Lengau API will bring tangible benefits to African weather services. It will help to improve forecast accuracy in regions with limited observation networks, offer a cost-effective alternative to traditional numerical weather prediction, and adapt to local conditions, and it will reduce reliance on global forecasting centers. And the Lengau API makes these advanced capabilities accessible to services with limited HPC expertise. It lowers the technical barrier and supports knowledge transfer. In practice, it translates to real-world applications such as early warning systems for extreme weather, agricultural planning, food security, water resources management, and public health interventions. But beyond operational forecasting, our API also has the ability to serve as a powerful educational platform to build climate science capacity across Africa. With this, we have created a progressive learning path. And by democratizing access to advanced weather forecasting through Anemoy framework and Lengau API, we are empowering African meteorological services, researchers, and students to build climate resilience across the continent. Our work contributes to improved forecasting for extreme weather events, lowered barriers to HPC for meteorologists, educational pathways for climate scientists, and a Pan-African collaboration and knowledge sharing. At the CHPC, we are making advanced computing accessible by developing user-friendly interfaces, creating documentation in multiple African languages, and building open source tools that work on diverse computing infrastructure, and designing modular workflows that scale from laptops to supercomputers. So, a vision for a resilient Africa. So this work represents a compelling blend of code, computation, and climate science, all controlling, all contributing to a more resilient and prepared continent through these AI-driven forecasting tools I've just shown you, optimized workflows, integration of traditional climate science with cutting-edge machine learning, and open source tools for reproducible methodologies. So future plans are to expand model coverage to include additional climate variables, enhance the spatial resolution for localized predictions, develop user-friendly interfaces for expanded models, and build capacity through training and knowledge transfer. And so that is it from me. Thank you. I'll take any questions or not.
Yeah, hello. Thank you for the presentation. If someone wants to find out more, do you have like tutorials, videos, or any sort of learning material available for how to do this? Like, where would I start if I wanted to learn?
So I've got a GitHub repo, but I'm making it private for now since I'm still developing some aspects of this workflow. But you could maybe, we could communicate there, or you could drop me an email and we can start the communication from there.
Thank you for the presentation. So I have a question. So do you have open source project where maybe you need more people to maintain the project?
Yes, we could collaborate on this one. Definitely.
Thank you for the great talk. The Lengau API, can that be extended to provide the workflow enhancements for other domains, or is it really tied to climate sciences?
It can definitely be expanded. I just kind of made it for my interest, climate science, but it definitely has the potential to address computational chemistry, bioinformatics, and so on and so forth.
So I'm interested in knowing how do you test the model to ensure that it is effective, and also what did you learn from that process? Because I know machine AI is non-deterministic, so it's just difficult to test to make sure that it works as the way that you want. So what was your approach with that? Yeah.
So the Anemone framework itself does come with some evaluation tools, but to make that process more robust, I've also integrated METplus, which is a standard toolbox for climate data evaluation. So those are some of the rigorous evaluation tests that we put the output through. Yeah, I think it's lunchtime, so.